Standing wave. Let us consider a system which is bounded on both the sides, such as a string is fixed at both the ends with a rigid body. If we produce a disturbance in such a system, then the wave created is known as standing wave. So basically, if we consider a string and we tie both the two ends of the string and produce a disturbance, then that disturbance will create a wave, and the name of that wave would be standing wave. Let us send a continuous sinusoidal waves from left to right. As soon as the waves hit the right end, they will start getting reflected and will start traveling on left side. If we continue the process, soon we will see that the waves are overlapping each other and will start producing interference. So what I'm trying to say that if we produce a disturbance on one end, then that disturbance will continue to the other end and then keep coming back to the same end. And when they do that, they will overlap and produce the interference. So what I'm going to do, I'm going to consider a system. In such system, at any point x and any time t, we will always have 2 points, one moving to left and other moving to right, which simply means that when the wave is moving from left to right, we will have 1 point going from left to right, and when the wave is going from right to left after like hitting the right end, then we have another point. So in order to explain this, what I'm going to do, I'm going to consider the equation when the wave is going left. So the equation of the wave moving to left is given as y1 x comma t is equal to a sine kx minus omega t. And when the wave is moving to the right, we can write the equation of the wave traveling to right is given as y2x comma t is equal to a sine kx plus omega t. Now what I want to do, I want to use the principle of superposition. So due to the principle of superposition, we can write yx comma t is equal to first wave plus second wave. So our equation is yx comma t is equal to a sine kx minus omega t plus a sine kx plus omega t. Now if we use the trigonometric formula and simplify this expression, we will get yx comma t is equal to 2a sine kx times cosine omega t. Now this equation represents that the waveform does not move to either side. So it represents a standing wave and having an amplitude of 2a sine kx. So if you look at this expression, this is my amplitude, which is over here 2a sine kx, and this is basically the equation of the wave. Now based on this equation, we have two things to talk about, and the first thing that we are going to talk about is nodes. So the nodes are when sine kx is equal to 0. When sine kx is equal to 0, then I can write kx is equal to n pi, and let this is our equation number 1, where n is equal to 0, 1, 2, 3, keep going. Now we know that k is equal to 2 pi over lambda, so I'm going to substitute that value over here, and if I do that, in place of k, I will write 2 pi over lambda, which is over here, times x, which is this x, is equal to n pi. If I simplify, I will get x is equal to n lambda over 2, and let this is our equation number 2, where n is basically 0, 1, 2, 3, keep going. The position of zero amplitude are known as nodes. So basically, when the wave particles does not leave their position, then that position is basically known as nodes. Now let's talk about the antinodes. So for the antinodes, the amplitude will be maximum, which is 2a if sine kx is equal to 1, and if we simplify this trigonometric expression, I will get kx is equal to n plus 1 over 2 pi, and let this is our equation number 3, where n is equal to 0, 1, 2, 3 dash dash. We know that k is equal to 2 pi over lambda, so let's substitute that value in equation 3, and if we do that, we will write 2 pi over lambda x is equal to n plus 1 over 2 pi, which is from here, after substituting the value of k as 2 pi over lambda, if we simplify further, we'll get the value of x as x is equal to n plus 1 over 2 pi over 2. and let this is our equation number 4, where n is equal to 0, 1, 2, 3 dash dash dash. Now the position of zero amplitude for this expression is called antinode. Now if I want to represent the nodes and the antinode graphically, we will get a graphical representation of nodes and antinodes like this, where these points are basically the nodes because the wave particles are not moving, and all the particles with A, which is basically the maximum displacement, which is these points on the wave, is known as antinodes. So basically nodes does not change their position, so they stay on the x-axis, and antinodes does their maximum displacement, which is basically on both sides of the x-axis. So nodes are denoted by n and the antinodes are denoted by A, and this is how we will define the standing wave.